So I enjoyed doing Christmas parades because then we went back to the studio and we cut it all and did it, you know, faked it. But we could redo it if we needed to.
So I wonder if I can ask.
Yeah, I'm sure they won't mind. Hey. Hey. Hey, I requested it. I said, get Chester out of here.
Anybody, but if it's easier.
Not yet.
No, we weren't.
We're setting it up. We hope the phone doesn't ring 42 times.
Right. Rolling. Can you tell me your name?
Yeah, I'm Brian Burden.
And where are we right now, Brian?
We are in McMurdo, Antarctica.
Okay.
It's a beautiful place down here. Lots of great sights and lots of neat things to see and do.
And what is this place?
This is the main hub for operations for the United States Antarctic Program. Pretty much every aircraft flies down to this point and then spreads out across the continent to different various areas where scientific research is going on.
And what does this office in particular do?
This office is the weather office. We're in charge pretty much of every aircraft that comes down, all the aviation aspects of the weather forecast for those pilots, starting in New Zealand all the way down to here, and then again spreading out across the continent to various camps for each research, and all the way to the South Pole and even Palmer Station on the other side of the continent.
This space takes information from all those different places.
Yes, it does. We have limited observations compared to what you would see in the United States. In the United States, you may see 1,000 observation points. Here, we may have 100 total, and some of those are actual observers that are doing that, and some of them are equipment that are actually doing it.
What kind of equipment?
We have remote sensors. Some are operated by the sun, solar, obviously. Some have batteries that are operated, and they send in information anywhere from every 15 minutes to once an hour. And it gives us various information such as wind birds, can give us the wind speeds and the directions. We can get, some of them have ceiling height indicators, can tell us how high the clouds are going to be. And then you have temperature and dew point, some of the same things you get on most sensors.
What are these ceiling height indicators?
Basically, it bounces some kind of beam off the bottom of the cloud that's there and tells me how high the bottoms of them are. Very important to the pilots because if their ceilings are low, they have poor visibilities, poor vision when they come in at those levels, and they want to know how high the bases are in those clouds to come in when they land wherever they're going.
And what about, so how many of those automatic weather stations are out there?
I would say here in the local area around McMurdo, we may have anywhere from 20 to 30 that are active, and then all across the ice shelf, the Ross Ice Shelf, which is basically most of the area between here and heading towards the South Pole, we probably have a total of 75 maybe that are pretty much active all the time, and various groups to use those. Wisconsin is one of the colleges that puts out some of those sensors. We have some of our own localized sensors in the area too.
And you also mentioned human observers. What is that exactly?
Right. Well, especially here at McMurdo, because we have 3 airfields at any given time, we may be running 2 of those. We have actual weather observers out there who visualize what they see. They see the clouds out there. They give us what the visibilities are based on what they're seeing, temperatures, winds, things like that. We have observers at the South Pole. And we have observers that are not quite as trained, but they have a good idea of what's going on out at some of the camps. And so you kind of add that all together and you get another good 10 observations at least.
Hang on a second.
Mm-hmm.
I'm just going to stop a second and see if I can maybe close a door a little bit and make it a little less. Okay, so we're talking about the weather stations around McMurdo and Antarctica. And so you get all this information that's coming in. You've got information from automatic weather stations, you've got information from ground observers. Where does this information go?
Well, overall, it eventually comes in here to McMurdo, and then it gets sent out to some of the colleges, Wisconsin, some of those others, and it can be put onto different formats where we can find it and get it from there. But mainly, it comes straight in here to McMurdo, most of it anyway.
And how does that information then turn into a forecast?
Turns into a forecast. Well, the big models that put out information or forecasts for the continent itself is called the AMPS program, basically. And the AMPS program gathers in all that information and puts it into its model. Just like the models we have back in the United States, we have one here for Antarctica. And that model then twice a day puts out information as to what it thinks that the forecast is going to be. My job is to take that, manipulate it, try to find out what's going to be happening in each place, and then put out a forecast from that. So all in all, it starts off as a big, wide, broad area of information pushed into a small little spot, and then that comes out and the model tells you, gives you an idea of what's going to be happening.
So when you talk about these models, is this something that is taking information from all over the world, weather stations, and then coupling that with, physical model information, or is this something that is just taking the Antarctic information?
This is mostly taking the Antarctic situation, but since it does cover a broad aspect, it does cover all the way back up to New Zealand, South America, areas like that. Those are incorporated into the system too. But again, with less information here, we're not getting quite as much as we would in other places. It makes it a little harder for the model to really hit what it's supposed to be hitting, and then that makes it harder to forecast.
And how does information about Antarctic weather or occurrences in the Antarctic atmosphere play into understanding the kind of the global situation?
Well, the model itself gives an idea, and then of course there are long-range models that show climatology, and all this information is pumped into that to try to help out for any type of global warming or cooling or anything that's along those lines. So the scientists will take a good look at that and try to figure out what's going to be happening over the years and years and years of information that's been coming in, and each year we seem to be getting bigger. A couple more maybe sites are out there that give more information. Maybe we start doing more upper air soundings that we start to see occasionally, and all that information is added in. It just makes the model better and better.
Do you think that it'll ever be possible to have perfect weather prediction?
Right now I would say no. That's probably something that never will happen. Unfortunately, we're in the business where 80% of the time we're right, but 80% of the people remember that 80% of the time that you're wrong, or that 20% time that you're wrong. So no, probably not a perfect forecast out there, but it's going to be pretty close. And even in the 20 or so years that I've been in the field, it's gotten better and better and better probably each year to every 5 years or so.
Why is it that you say, does that have to do with the kind of chaotic nature of weather, that you'll never be able to have a perfect prediction, or?
Yes, I would say you definitely have to go along with those lines. The physics is there. We know what it should be doing all the time. It doesn't always do the same thing. And your sensors are not perfect either. Sometimes you get erroneous readings from those, and especially here where you have limited sensors, it makes it even harder.
What's special about the Antarctic weather situation? What's interesting about it to you?
Well, they call it the coldest, driest, and windiest place on Earth. You've probably already seen that. And there's a lot of little nuances to this place that you really don't realize until you've been here a couple seasons. There's a lot of topography that really needs to be taken into consideration. Even though it seems like it's flat and white everywhere, it's not. We got the Transantarctic Mountains that cut through the continent. So there are a lot of things, small things, that make for different changes in each system. Anywhere from high winds to no winds, depending on where you're at. And it can only be a mile difference. And you can have 50-knot winds or 4-knot winds.
So, just on this monitoring idea, in your experience, I just find it really interesting that there's these automatic, kind of machine-based weather monitoring systems, and despite them being so high-tech, you still have human beings on the ground monitoring the weather. Can you talk a little bit about that and why?
I think if you really look at it in an aspect, even with the automatic equipment, except for some of the sensors that are out here, you kind of need someone to keep an eye on it to see if it's giving you good readings. Well, if you have a person out there, a lot of times the pilots have a good feeling that they're actually seeing what it is. There's some limitations on some of the sensors too. For instance, it's only going to read what's right above what the sensor is. It's not going to read what's coming in from the west. It's not going to read what's coming in from the east. It's not going to see those changes. Yes, you're going to get the data, the rapid temperature changes, those kind of things, but some of the other things, the automatic equipment has some flaws. So that's where our people make up the difference, and that's why they're at the main airfields. So the pilots know they've got a backup. Both things are at each airfield. They'll have a good solid forecast and a good solid observation when they come in.
And do you think that someday there'll be automatic weather stations that can equal what human observers can see and predict?
It depends on the equipment itself. Down here, very harsh continent, very harsh weather. Hard for the equipment to stay up all the time. They have to